All right, here we go. Welcome, lesson 10.2, geometry notes on finding arc measures. Uh, that's basically it. We'll jump in. We'll figure out what the heck is an arc. We'll talk about a little vocab. Um, figure out what does it mean to measure an arc, and then the last two concepts kind of go together with congruent arcs and congruent circles. So let's do it. Let's get into it. Kind of a shorter deal, hopefully. Let's first part. So get the picture definitely. We've got a circle, right? Circle C, as we talked about in the previous lesson, naming a circle. So the first part, the first feature, like new feature that we're seeing here is what's called a central angle. So it's this angle ACB. So I didn't mean to write right over the top of them there, but ACB, whose vertex, right? Where's the vertex? It's the center of the circle. So we're actually talking about that angle ACB would be our example there. By just drawing that, or inserting that central angle there, we've now sectioned off our circle into two parts, in what's called a minor arc and a major arc. You can kind of see them highlighted there in red and blue. Let's start with minor arc. So an arc is just a part of a circle. Okay, so we're not the full circle, but picture kind of snipping this little piece, just this little that red section off the circle. That's what would be an example of an arc, or potentially, a very big arc, which is the majority of the circle all the way around from here to here, but just that blue part. Okay, so minor arc. We'll talk about the measures on the next slide, but basically the kind of the threshold is what makes something a minor arc. It has a measure less than 180 degrees. Okay, so you can see how it's named right here. We name it using, almost thinking of it as like the endpoints, those points of intersection. So A and B kind of act as like an endpoint would with a segment. And we only use two letters. So, and you can see the abbreviation right there. We would still say arc. So that's why I'm using the quotation marks, arc AB. But you can abbreviate it right here, arc AB. All right. And again, we'll get to the measuring part in just a second, but just for right now, understand that this would have to be less than 180 degrees. We switch like form a little bit when we start talking about what's called a major arc. So now we're talking about part of the circle that's beyond that 180 mark, 180 degrees to 360. So this blue arc would be what's called a major arc. The reason we need a different naming system, because the endpoint, the quote unquote endpoints of this are still A and B, right? If I go all the way around the circle starting at A all around to B, we can't just call this arc AB again, because, well, you wouldn't know what I'm talking about. Are we talking about the red one or the blue one? So for a major arc, you can see the one difference is we add a point along the way. So point D, we just need another point to kind of name it. So you're going to use three letters for a major arc. All right, so we'd still say arc ADB, and then abbreviate it the same way we did before, ADB, with just a big old arc over the top. All right. The last part, one that you've seen, I'm sure, and heard in other situations. We'll add it on here. It's not a part of our picture yet. We don't really have one drawn, but a semicircle. So what did I just draw? Going back to the previous lesson, a diameter, right? So if we just kind of pick up the lettering system, we got A, B, C, D, E, F. So I've drawn a diameter, EF. That's right, a chord that passes through the center of the circle. But essentially what I've done is cut my circle into half. And hopefully we know from just previous courses maybe that a circle's measure is 360 degrees. If I cut it in half and we're exactly 180 degrees, a semicircle is an arc with endpoints that are the endpoints of a diameter, or whose measure, you could even say it part of a circle, just to kind of word it the same as these ones, part of a circle measuring exactly 180 degrees. So as far as naming goes, we got to add that part too. How would I talk about one of these semicircles. So let's say I wanted to talk about this part of the circle right here. That's semicircle. We're going to use the 3-point method, like we did above here with the major arc. So one of our semicircles on the diagram, we would say we could still call it arc E D F. So it wouldn't look any different than a major arc as far as using the 3 letters, starting with the quote unquote endpoints and using a point in the middle. But and we wouldn't abbreviate it any other way. It would still look like arc E D F with a little arc above the top of it. So just kind of on the surface, you can tell a minor arc just by the name. It's got 2 letters. That's got to be a minor arc. If you look at a 3-lettered one, without seeing, you have to be able to see the picture to determine, hey, is that a semicircle or a major arc? Okay, and we'll talk about right here in the next one about, all right, well, how do I get to these measures? All right, so that's the basics: arcs, major, minor arcs, semicircle, our central angle. All right, keep her moving. So now when we actually talk about measure, there's a lot going on here. I think the heading-wise, you can just get something up as far as just arc measure or measuring arcs. The major takeaway is on our, and it's a very similar picture to what we just had. The measure of the central angle is the same as is the same as the arc that it forms. So the central angle. So there's 2 different things going on here. The measure. So like this angle ACB, the measure of angle ACB is 50 degrees, right? And that's actually talking about that angle ACB as an angle. It's 50 degrees. The way that arc measure is defined is the arc, the measure of arc, and here it is. Here's a new abbreviation for us. Arc AB happens to also be 50 degrees, but remember, we're talking about a different piece right here. We're talking about the piece that just runs from right here, from part A to part B as part of the circle. So if I were to draw that arc just kind of separate from the circle, it would look like this. Arc AB has a measure of 50 degrees. And notice, just like an angle, we had the little M for measure, the measure of angle ACB, the measure of arc AB being 50 degrees. All right, so that's kind of the big reveal there as far as how do we find arc measure? We need to look at the central angle, and then my arc measure is going to be the same as that central angle. Okay. There's an angle addition postulate here that I'm not even going to have us actually add to our notes, but it's basically just, it works the same way with the angle addition postulate and segment addition postulate, saying that, you know what, if we ever need to add 2 arc measures together to get a larger arc measure, that's fine. Like, that's okay to do. And that kind of ties in here too. So if I know the entire circle is 360, if you need to add that to your notes. The major arc here now, the measure of arc ADB, right? This bigger one, you can see it right here, is 360. The full circle minus this 50-degree arc one, this little red one, is going to leave us with this full 310 degrees right here. So you can definitely have arc measures that are larger than 180. We'll definitely have ones. A semicircle, we said, would measure exactly 180. So yeah, that's kind of the bulk concepts as far as the lesson goes. Let's look at a couple examples where we practice them here. But yeah, we'll skip over it. So I'm not going to say anything about this slide here. I just, to avoid confusion, I think most of us will be able to handle it here. So pause it, sketch in your notes real quick, or if you got the notes handout that goes along with it, give it a shot. And here's a solution. So you've paused it, you've tried it. Find the measure of each arc on circle C. So we got the circle where DF is a diameter. That's kind of important for us. It's telling us that DF, and we can see it, I think, F is passing through our center there. So here's my approach, and I would encourage you to do the same. I usually go through and fill in any unknown central angle measures. So from here to here, this being a diameter, I should hopefully know that that's 180 degrees. And then as far as, so that angle, that's a straight angle. And then just the only thing I need to figure out is what's the measure of this angle right here. And I can use stuff with this 180. I could also go 360 minus 180 minus 117. And hopefully, without too much difficulty, figure out that that would be a 63-degree angle. And then so I think by having all these numbers on the page, there's not a question they could ask me that I wouldn't be able to answer. Now, I guess the last part would be, going back to the first slide, we need to hopefully interpret, like, when I see DE, the arc, what is the measure of arc DE? First off, I'm going to write my answer as the measure of arc DE equals, and there's two ways to get from D to E. Should I go this way, or should I go all the way around this way? And the two letters tells me, hey, that's the shorter path. So from D to E this way, that's the way I would have to travel. So the central angle is 117. That means my arc measure is also 117. Okay, so don't make it harder than it is. We're using those central angles. A lot of times I wouldn't even write this out here, this 117, just because I know the concept that this and this should be the same. All right, let's look at the next one. The measure of angle, or I'm sorry, not of angle, of arc, DFE, starting at D. It's like a road map. Then if you got the three letters, just follow it and make sure you hit them in that order. So I got to travel all around the outside of the circle from D, make sure I hit pass through F, and then finish up on E. So there's two different ways I could figure out this measure. Maybe the easiest way is just to add the 180 that we traveled from here to here, plus the 63. You could go 360 and take off the 117. A couple different options there. We end up with a measure of 2. What do we got? 243. I was like forgetting what I was doing for a second. All right, sweet, awesome. So far, so good. Hopefully, last one. Now these look the same, right? DFE, DEF, it's the same letters, but obviously, it's a different kind of path to get from one spot to another. So now we're still starting at point D, but I'm traveling this way and passing through E and stopping on F. So that's one that I travel. I end up on both points of that diameter. So I could add the 63 and the 117, or I could just say, hey, you know what? This is a semicircle. This is 180 degrees. So that's that. Hopefully, very doable. Let's jump ahead here. Look at example 2. Really, the only difference is, it's split up a little differently. You got 4 sections, kind of 4 slices of the pie here. And then I'm also asking you, in addition to finding the measures, identify each as a major, minor, or semicircle. So you could do either one first. Something that we talked about, obviously, with the 2 letters, I could go through and say, hey, that's a minor arc. Let's see. Oh, that's got to be a minor arc, and that's got to be a minor arc, just simply because it's got 2 letters. There's no other way. There's no other type of arc that could be. These ones we did say with the 3 letters, we're going to have to wait and see kind of how they show up. But let's maybe do that first part where I think if I can figure out what this one is here, we'll be in pretty good shape. So it looks like it doesn't tell me I have a diameter, but I know because of the numbers, 120 plus 60 is 180. So that means from here to here is 180 degrees, making segment TR a diameter. So if that's 180, this has to be a 180 here. So it actually kind of works out nicely where this is exactly 100 degrees. Sweet. All right, let's do it. Let's do the measures. Let's get all these done. Measure of arc TQ. Let's see, from T traveling over to Q. No problem. Just don't confuse myself. I'll look right here and say, hey, that's my 120. We'll do each part, and that's a minor arc. All right, next up, we'll try to see if we got enough colors to do one for each one. Q, measure of arc QRT. Let's see, starting at Q, travel through R and get all the way around and finish at T. So let's see, I'm just going to go 100 plus 80 plus 60, 240. That would be a major arc because I've traveled more than half of the circle. That's the other way to think about it too. Like we've traveled more than halfway around. That's going to put us at a major. Next one up, let's see, a new color. The measure of arc TQR. Let's see, start at Q, get around to Q, stop at R. All right, there's our semicircle, halfway around, TQR. We're talking exactly 180. And we can just say semicircle. A couple more here. What do we got? What do we need? A red? How about that? The measure of our QS. I can tell already it's going to be less than 180. Let's just see. Start at Q. Get all the way around to S. So this 100 plus this 60. We're talking 160 degrees. Minor. How about purple and blue? Measure of arc TS equals, start at T. I know it's going to be less than 1A, so from T to S is 80 degrees. That's another minor arc. And last but not least, what do we say blue we were going to go with? The measure of arc RST is what? Start at R, pass through S, and finish on T. Oh, look at that, another semicircle. Half the circle, so 180. All right. Pretty colors and everything, looking good. All right, so that's the bulk of the lesson. We do have one last thing here to finish up with. So just a short note, quick example, and that'll be that. So switching gears here a little bit. So congruent, let's do one at a time. Congruent circles. What does it mean for two circles to be congruent? Well, two circles are congruent if they have the same radius. That's like short and sweet, plain and simple. So if I have a circle A and a circle B, and I say, are those congruent? You say, I have no clue, until you know that, hey, this radius is the exact same as that radius. Now I'm good. I don't even need to, I don't have to say a name for it, but I could definitely tell you that, circle A is congruent, exact same size and shape as circle B. Okay, we could obviously get numbers in there if it told me this was 10 and this was 10, so stuff like that, but they got to have the same radius. So that one's pretty straightforward. So second part then is congruent arcs. Remember, congruent, I said it a second ago, it's same size, same shape. So there's kind of two parts to it. First and foremost, you have to have the same measure. If you have two arcs with different measures, there's just no way they could be congruent. They have to have the same measure. And then there's kind of like a two option way that we could say that to know that they were congruent. We could know that they're on the same circle, or they were on different circles, but I knew that those circles were congruent. So let's illustrate those here in our notes, and then we'll look at the last example. So let's say I've got circle A again, and I've got an arc that's 75 degrees. We'll call it arc BC. Oh, I think that's the same number as the example in the next one. Must be on my brain here. And then I've got, so it's going to be actually exactly the same. A different arc DE, but I also know it's the measure of the arc is 75 degrees. Well, there's no way that these could be different. So remember, what are we actually talking about? Don't get lost on arcs and this is easy, arc measure and stuff like that. We're actually comparing this like little short kind of curved piece right here, that arc BC. We're comparing that to this arc right here, DE. DE, and we're saying like, hey, yes, this arc is exactly the same size and shape as that arc because they're on the same circle and they have the same measure. All right. The second situation would be two separate circles, right? So I've got, let's do kind of a smaller one here. A 20-degree arc AB. And then I have a totally separate circle over here that has another 20-degree arc on it, arc CD. As of right now, I don't know those arcs are congruent. What? They both have a 20 measure. Well, it doesn't matter because we don't know if the circles are congruent, but I guess all it takes is a tick mark there and there to say, oh yeah, absolutely, arc AB now has to be absolutely identical, congruent same size, same shape as arc CD. Okay, because they're on congruent circles, because of the radiuses being congruent, and they have the same measure. I guess the one, maybe just to kind of illustrate it here, we did it in class, I know that I could have potentially a really big circle. Let's use an easy number here, 90 degree. So this arc right here, AB, has a measure of 90 degrees. Hopefully that's no big deal, no problem. Let's say I have a different circle. It's got a 90 degree arc. Arc CD. Oh, that's also 90 degrees, right? It's got the right angle in the middle there, and that's pretty accurate. I don't think I've taken too many liberties. But now if I were to pull these arcs out and look at them separately, well, here's arc AB. Okay, and then here's arc CD. Nobody is going to make the argument, oh yeah, hey, that orange arc and that green arc are the exact same size and shape. What? Like this one's way, way, way bigger, right? So that's just maybe to illustrate just having the same measure is not quite good enough. Like we got to know that the circles were congruent. All right. So last thing is kind of just putting that all together. There's a 75 that I mentioned a second ago. There's some 90. So like I said, I must have had this on my brain from earlier. What are we being asked to do? Tell whether the given arcs are congruent, explain why or why not. So there's a little bit of an explain. You're just going to kind of reference some of the stuff we just talked about. Okay. All right. So we're talking about arc, and for part A here, arc BC, which is right here, that has a measure of 75 degrees, and arc DE, which is right here. Oh, hey, look at that. Also 75 degrees. So same measure, absolutely. And they're on the same circle. So yes, absolutely. Let's say it. BC, arc BC is congruent to arc DE. So we can say it just like that yes, they are congruent. How do you know that? Because, I mean, short and sweet, they have the same measure, which is what? 75 degrees. And we said that's not good enough. Let's also say and on the same circle. Okay, so it's that second, I mean, they're both important. We can't say one without the other. But both of those would have to be true in that case, okay? I'm just going to scroll here. It's a little bit easier to write if I'm a little higher on the screen. All right, so I've got, oh, now I need to see the arcs we're talking about, though. We're talking about arc AB. So from right here to right here, and we're comparing that arc to arc CD. What do we think? Arc AB, let's do a more fun color. Arc AB, is that congruent to arc CD? I would say no. What? Why not? They both have a measure of 80, right? So this, if I were just to focus on the red one, this central angle on this circle, yeah, for sure. That's an 80-degree arc measure. Here's the problem. This is a different circle, right? On this blue circle, it has a different radius. This little blue segment right here is longer than that red segment right there. So two different radii, although we both have a measure of 80 for the arcs, arc CD is going to be a little bit bigger. So how do I explain that? How do I say that? So I would definitely say, hey, these are not congruent. Why? Arcs have same measure. So I'm kind of acknowledging that there's some component to this that would almost make them congruent, have same measure. Man, that says measure, which is 80 degrees. But now this one, instead of like an and, it's more of a but. But are on that's supposed to be C, congruent circles. Or, you could say are on different circles, or on, something along those lines. All right, last but not least here, I think it's our last situation of a yes, kind of got squeezed out a little bit. Maybe we'll write it above. So we're talking about arc FG and arc HJ. So I would definitely say that yes, arc FG is congruent to arc HJ. How do you know that? They have the same measure. Now, again, we looked at this one a second ago. There's no number, but I can tell because of that 90 degree right there that they both have a 90 degree measure. So same measure again. Let's say that's actually been true for every single one of these. They've all have the same measure. So 75 and 75, 80 and 80, 90 and 90. But they're 90 degrees and are on congruent circles. And I think that's good. I mean, you could look at the markings and say, hey, there's a tick mark here, tick mark here. The radii are congruent. That's what makes the circles congruent. But I don't think we need to say that. I think we could acknowledge it that, hey, those are congruent circles and say we're okay. So there we go. There we have it. Awesome. That last part was kind of tying those last two big ideas together. So I really started with here, proving circles are congruent, got to have the same radius, identifying congruent arcs. Okay, they got to have the same measure, and then they're either on congruent circles or are on the same circle. And then we did a whole bunch of that, finding arc measure of a circle. So we're good. We've done it. 10.2 is in the books. We'll call it there. I will see you in future lessons.